from 323 to 299 million years ago. The cause of this event was from the ecosystem becoming drier, changing the habitat of the rainforest and wiping out many of the dominant amphibians at the time. Scientists believe that the cause of the Carboniferous rainforest collapse was glaciation, which caused the temperature to drop and fluctuate over the latter half of the Carboniferous period. The sudden changes in climate during the Carboniferous period caused the hydrosphere to dry up. Many of the bodies of water in the Carboniferous rainforest were swamps, and they allowed amphibians to thrive. But when temperatures dropped and it became more dry, many of these swamps dried up. The atmosphere humidity fell and became more arid, and the lower temperatures resulted in less precipitation because there was less evaporation of water. The geosphere was affected by the Carboniferous rainforest collapse over periods of time when all the dead plant life turned into large deposits of coal in the earth, which is used today to understand the plant life and details of the Carboniferous rainforest collapse. Several species went extinct as a result of the climate change, and because the land became drier, amphibians had a harder time dominating the ecosystem as they once did before, giving mammals the opportunity to reproduce and be genetically favorable. Some scientists believe that an ancestor of Homo sapiens lived in the Carboniferous rainforest. Because of the collapse, our mammalian ancestor was able to reproduce and become more dominant in the food chain, allowing humans to make it through the evolutionary process. In addition, lycopsids and other plant life were significantly affected. Lycopsids were large, dominant plants of the Carboniferous period that died off during the collapse and were replaced by tree fern forests. Lycopsid forests were more open while tree fern forests were more closed off. Since lycopsids made up a significant amount of the habitats that house many of the organisms in the forest, changes like lycopsids to tree fern forests put evolutionary pressure on organisms living in the habitat. Changing temperature and humidity heavily affected plant and animal life, which rippled throughout the ecosystem.
So, for some background for the Carboniferous forest and how it ended up getting decimated, was because as gas concentrations in the atmosphere, particularly CO2, as those levels fluctuate, it creates colder or warmer climates, and in this case, lower levels of CO2 led to much colder and drier climates. And this ended up feeding back on itself because the cold levels led to more and more glaciation in sort of a ice kind of environment. And then all this ice led to higher albedo levels, which would then reflect the heat back out into the atmosphere instead of being absorbed onto the land. And this dry and cold climate ended up being the downfall of the Carboniferous forest. So, how we know how this change occurred in the Carboniferous forest and how we know it was destroyed, it's because Carboniferous means coal-bearing. So, during these periods of great climate change, a lot of the vegetation from the Carboniferous forest turned into peat and then coal over time. So looking at coal beds tells us how and where the vegetation became scarce, and highlighting how the wet and hot cycles got shorter over time. And scientists believe a glacial period is the cause of these patterns, because fossil records show that the latter half of the Carboniferous period, there was a shift back and forth between wetter and drier species of plants between around 323 and 299 million years ago. So therefore, you can tell this period of climate change occurred by viewing the similarities between the types of plants and the animal fossils that are found in the ground coinciding with this period of time.
In the beginning of the Carboniferous period, oxygen made up about 20% of Earth's atmosphere, similarly to what it is now. Early in the Carboniferous period, Earth's climate was warm. Later, glaciers formed at the poles, while equatorial regions were often warm and humid. Earth's climate became similar to today's. shifting between glacial and interglacial periods. During this time period, the earth became cooler due to many of these dead plants being buried so deep in swamps that their oxygen levels were cut, and they no longer had the ability to decompose and contribute to the release of greenhouse gases back into the atmosphere, thus decreasing the amount of carbon dioxide in the air. Those plants that were buried deep in these swamps have now turned to coal due to applied heat and pressure for millions of years. The Earth has become warmer since this period because we now rely on these coal reserves for energy supply. We are now burning these reserves and ultimately sending the carbon dioxide back into the atmosphere. Like the Carboniferous rainforest collapse, we have outlier levels of CO2 in the atmosphere. But unlike the CRC, we have far higher levels of CO2 causing higher temperature, while the collapse had lower levels of CO2 resulting in lower temperatures. The Carboniferous rainforest collapse can be used to show how low CO2 affects temperatures and environments, and how changing climates can result in catastrophic effects for ecosystems. It shows how mammals and other tetrapods are better suited to adapt to more humid climates than many large amphibians which died off as a result of the arid climate and dried up swamps. This information is very relevant today, where we are putting a lot of CO2 in the atmosphere and changing its natural composition. Looking back at climate collapses of the past, especially those that were caused from changes in CO2, can help us predict what level of CO2 change and what temperatures could affect which ranges of organisms today. Data like this allows us to build prediction models, which gives us a better understanding of how resilient our forests are and how they function, allowing us to better preserve them today.